Hello students, in the today's class we are going to discuss about Reimer Tiemann reaction. The Reimer Tiemann reaction, it is one of the important electrophilic substitution reaction of phenol. And we know that the phenol molecule on reaction with sodium hydroxide aqueous and chloroform. While treating with these two, we will be getting an intermediate as follows: ONA, and it has got CHCl2. This intermediate is commonly called dichloro benzol derivative. Benzol dichloro derivative is formed. This on further reaction with sodium hydroxide, we will be getting the product as follows: ONA, and this is going to be the CHO. This on acidification, we can get a final product as follows: OHCHO. This compound is called as salicylaldehyde, ortho substituted compound called salicylaldehyde. In the ortho position, one hydroxy group is found, and hence its other name is orthohydroxybenzaldehyde. So this is a preferential product, preferable product rather than the para product. So how to understand this reaction? For understanding the organic conversions, the mechanism is always important. So in which mechanism the reaction proceeds? When you understand the mechanism, you can have a further clarification. Just I'm explaining the mechanism. Just take a phenol having this formula OH on reaction with the sodium hydroxide NaOH. This is acidic in nature and this is basic. So when these two are reacting with each other, we can have a sodium phenoxide plus H2O. So here the H is going to combine with this OH to form H2O. So we are getting the sodium phenoxide. So rather than starting the action from the phenol, we are going to start it from sodium phenoxide. What about the other reagent, chloroform, CHCl3? On reaction with sodium hydroxide, what is going to happen? The chloroform in which the carbon is bonded with three chlorine atoms and one of the hydrogen. All these chlorine atoms are more electronegative, and this hydrogen is acidic hydrogen. So the acidic hydrogen can be abstracted by this OH present in the base, so that we can have CCl3 minus plus H2O and as well as Na plus. So in the first step, you can have an anionic part like this CCl3 minus, and to generate an electrophile from this, in the next step, here it is carrying minus. The Cl is leaving as Cl minus because it is going to combine with this Na plus. So due to this Cl minus removal, we will be having an intermediate as follows. Two chlorines are bonded with the carbon, and this electron pair is present on the carbon. It becomes a dichlorocarbene intermediate. This dichlorocarbene intermediate can behave like an electrophile. How this can be substituted in the phenol? That matter is given as follows. The dichlorocarbene intermediate obtained above is going to react with the sodium phenoxide as follows. The phenol, now it is in the form of phenoxide, Conveniently, in the ortho position, one of the hydrogen is taken outside. CCl2 dichlorocarbene is going to behave like an electrophile. The reaction proceeds as follows. The pair of electron present on the oxygen is moving towards this side. There will be double bond. Parallelly, the bond breaks up and electrons are available for this particular carbon. Execute these two changes and find the result. This will be the result. We will be having double bond O. One hydrogen is there. Now this is going to connect it like this. The carbon is getting connected with two chlorine atoms. Now this carbon intermediate is joined with the benzene ring. Once a new bond is merged, this extra pair of electrons carried by the carbon that is written as minus now this intermediate. In the very next stage, what is happening? The hydrogen is leaving as H plus and electrons are available for the ring, and this bond is moving back. Oxygen can carry minus. It is just because of the availability of this pair of electron to this hydrogen. The hydrogen will be combining with this carbon to form CH. So this electron pair is moving towards the ring side and the bond is breaking up. Oxygen is carrying minus. Execute this change and find a product. We can have a substance as follows. Here it will be O minus. Here we can have CHClCl. The dibenzol derivative is now obtained as an intermediate. This intermediate formed can be treated with the sodium hydroxide. On treating this with sodium hydroxide, this matter can be simplified as follows. On reaction with the sodium hydroxide, two molecules we can take. So automatically NaCl and NaCl is formed there. Due to this hydrolysis, this would be the result. We will be having, here I can write O minus, and here we will be having CHOHOH. It becomes gem diol type. And we know that it is highly unstable as it is having two OH group, and from that the H2O is leaving. And due to that we can have the sodium derivative, which means sodium phenoxide. It is going to have CHO group. Now this is to be acidified in the final step on treatment with the H plus from the acid called hydrochloric acid. This O minus can give electron to this and the Cl is leaving a Cl minus. The Cl minus what is left here can combine with Na plus to form NaCl. So this is the product expected. Yes, in this particular product, ortho position is containing hydroxy group and hence it is called as orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde is also called as salicylaldehyde. So it's a final product. So it is the major product expected ortho product and minor product is the para product, para hydroxybenzaldehyde. So the reaction mechanism can be followed in the easiest way. Just a glance, just see here the dichlorocarbene intermediate which behaves like an electrophile and gets the electron from the benzene ring. As the oxygen is giving an electron, this pair of electron is available for CCl2. We can have an expected intermediate like this, and after the formation of this bond, the carbon is going to carry minus. This can be neutralized by giving electron to the hydrogen so that the hydrogen can be bonded with this carbon atom and this pair of electron is moving towards the ring side. Parallelly, the bond is broken and oxygen can carry minus. That you can have an intermediate like this. This on hydrolysis by using two molecules of sodium hydroxide, we can have a gem diol type product. It's unstable. To make it stable, one of the water is getting eliminated, and this is to be acidified finally by using the hydrochloric acid. Oxygen, that O minus from the sodium phenoxide, is giving electron to this hydrogen, and the Cl is leaving. That Cl can combine with this Na available to form NaCl, and the final form of product is orthohydroxy benzaldehyde. So this is the reaction mechanism applicable for Reimer Tiemann reaction.